Well, thank you everyone for joining our discussion today. The topic of our talk will be from project team to product team, an interdisciplinary approach to STEAM education. So we'll first start with the agenda. I have a quote here that says, technology is best when it brings people together. I have a picture that I included in this overview slide or agenda slide. And this is me on the left with the blue shirt with some of my former colleagues from AT&T at a hackathon at AT&T Park in San Francisco at the San Francisco 49ers stadium. So the first thing that we'll do is we'll talk a little bit about us, the presenters. Then we'll get into some technology and innovation projects and experience that we have. And then we'll wrap things up with our approach and perspective of STEAM education. So our team. So I'll start with myself, Corey Harris. I'm the president and CEO of HBI STEAM Academy. Also, I'm a former high school computer science teacher. And I have my colleague here, Brian Haskell, who's a principal project manager at AT&T. And Brian is also currently a college computer science professor. And we'll turn it over to Brian for an overview of who is Brian.
Thank you, Corey. So again, my name is Brian Haskell, and I'm, as Corey said, I work currently as a principal project manager for AT&T, as well as I teach courses, business management courses, computer science courses at a variety of different institutions, including DeVry and Liberty. I earned my bachelor's degree at Clark and Lane University in computer science. Also, I have a master's degree in computer science and a second one in information systems from the University of Maryland, Baltimore County, as well as I have a master's in business administration from Kansas, University of Kansas. Some of the things that I love to do, I love crossword puzzles, I love playing softball and playing chess with especially my boys in particular. They let me win. I'm still trying to teach my girls how to play chess. I'm also project management certified through the Project Management Institute. And I love teaching, I love learning. And so I'm looking forward to going through just some of the things that I've learned over the years in my experience and how they apply to STEAM and innovation. So back to you, Corey.
Okay. And thanks, Brian. So once again, my name is Corey Harris. I currently live in Woodstock, Georgia. I grew up in an area called College Park, Georgia, that's close to the Fulton County or the Atlanta airport. I received my bachelor in computer science and mathematics from Clark Atlanta University. And I was a part of a dual degree program, a 5-year program where I went to PreK for 2 years. And I received a bachelor's of electrical engineering from Georgia Tech as well. My focus there was communication systems and biomedical engineering. Those were my specialization courses. I also received an executive MBA from Kennesaw State University and served as the alumni president of the Kennesaw State University Executive MBA Alumni Association. I was president for 2 years. In terms of work history, I've worked at T-Mobile and AT&T, so I've been in the wireless industry my entire career, serving at different capacities. One of the interesting projects that I worked on at Singular Wireless and AT&T was the merger between the two companies. I was the architect that focused on integrating the network systems between the two companies, and also had the pleasure of working on the iPhone project as well when it was launched at AT&T. I have two companies that I started, HBI Ventures, which focuses on growth stage companies. And I also started a after school program for students in STEAM called HBI STEAM Academy. And we've been servicing students since 2016, mainly from the Atlanta public school system. My most recent job before focusing on the STEAM Academy full time was with Kimberly-Clark and Kimberly-Clark Professional, and I was the R&D lead for the connected systems at Kimberly-Clark. One of my passions, and Brian knows this, and everyone that knows me knows this because I talk about it all the time. I enjoy cooking on my green egg. I really enjoy it. You can find me I make my own spices from scratch, sauces, and I just love doing this. Okay. Brian?
Sure. So one of the things that we try and focus on here is moving from project teams to product teams, and how do we integrate the things that we learn from a scholastic or from an academic perspective, and how do we then apply them in the real world? So these are just some examples of some of the things, some of the projects that I've worked on, whether it's from both a professional capacity as well as some of the projects that I've worked on within my academic settings, and how do I incorporate the two together, even though they are two sort of distinct entities. So one of the first things I did when I worked for Verizon, because along with Corey, I have a long career in telecommunications. So Verizon was one of the first companies I worked for, and we did a ADSL deployment, or asymmetric digital subscriber line. The technology is not used as much more DSL these days, but when we originally started with networking, it was important to get this technology out and work with a number of different disciplines or a number of different organizations within Verizon in order to make this deployment happen. So it takes more than just working with engineers or working with just project managers. But me as the project manager, it was important for me to understand the different disciplines and to develop a plan that brought all of us together in order to meet this common goal and to meet this deployment, not only in a timely fashion, but in a cost-effective fashion and with the best quality possible. So moving from there and applying that into an academic setting, one of the things that I had to do with one of the institutions that I worked for was to redevelop our project management course. So I teach a course in project management. And so one of the things we had to look at was, what's some of the technology that we're using, whether it's how we do our discussion boards, how we do, just basic assignments using Microsoft Project, because that's, pretty much an industry standard from a project management perspective. And building on the students' ability to use that technology, because it's one thing to talk about it and to give them the software, but it was very important for us to look at how do we really build stamina, so to speak, in the course, because courses are about 8 weeks long, and so understanding week by week, having these little projects to do each week to kind of help them understand, okay, this is why you have a project plan. This is what a critical path is. This is what your tasks are. This is how you develop your durations for specific tasks. And so these little things to kind of help them understand what they're doing, but not only what they're doing, but why they're doing it and why it's important, especially when you start applying that to a real world situation. So one of the things that I really focused on as part of this redevelopment was what kind of real life scenario, what kind of real life situation can we incorporate into the course to really help students understand not only what we're doing, but why we're doing it. Moving on from there, another sort of technology deployment project that I did working in at AT&T was creating these national data centers. And again, this was another opportunity for me to work with a variety of different disciplines within the organization to understand not only how we get to deploying these different technologies and different pieces of equipment in the technology centers, but what are some of the sort of the devils in the detail, and what are some of the points of pressure or points of contention that we may need to focus on that one discipline may not necessarily see or understand from a different discipline. And then lastly, I also had to do a development course for certification. A lot of what we do in technology isn't necessarily just about what we learn or what we apply in our professional lives, but there's also, again, the academic piece of it, or understanding it from a systems perspective and understanding how things should work or be applied, and not necessarily how they are in real world life. So one of the things I did working with, again, other people within the institution, understanding, what are the requirements, understanding, developing a design and a development of a plan in order to incorporate student feedback, getting, feedback from the students and understanding what's important to them. And so again, just looking at a variety of different ways in which to incorporate other organizations or the other disciplines within the organization so that we can then develop a product that we all could be proud of, that we could use to the best of our ability. Corey?
Okay. All right. Thanks, Brian. So when considering both school projects and school project teams and corporate product teams, there are three important components for success: critical thinking, interdisciplinary learning, and student asset-based learning. And what we do, we look to incorporate these components on solution-focused teams. Much of what Brian mentioned in terms of the projects that he worked on at AT&T and other companies, these were solution-based, solution-focused teams, whether it be products or solutions. And I have a success story for, well, actually two of them, that's around the student asset-based learning component for a student that was a part of my HBI STEAM Academy in partnership with the Urban League of Greater Atlanta. We had a student that was working, he was a part of one of the technology cohorts. And this particular cohort was, they were challenged to come up with a solution to engage their peer group. So these are 6th through 12th graders. And we have one student that was, it was actually the mayor's, at the time, the mayor's nephew, who was still trying to figure out the direction that he was going to take in terms of career. He was a very good artist. So what we did is we did a skills assessment, we organized the teams, and he actually was responsible for the user interface, the look and feel of the application that they developed. So his takeaway from that experience was that he could leverage his natural skill set of being an artist and incorporate that into a technology field. And he went on to college and majored in graphic design, and is actually working for a startup right now doing that work. We have another gentleman who came into the program who was headed down the track of heating and air. And he was actually on the same cohort of students. And he actually served as team lead of his team. And he came up with the project itself and really led the team. So and that team won first place that year. And based on that experience, he ended up, instead of going into heating and air, he enrolled at Jackson State University and is currently working on his master's in business administration at Howard University right now. So when we think about critical thinking, what we're focusing on here is creating a strong and practiced skill set of thinking with a creative solution mindset. And this is important in the classroom and in when we talk about the real world, working on product teams and project teams. And then the interdisciplinary learning, and Brian touched on this a little earlier, about having teams that make up different disciplines. So if we look at a product team, you have marketing people on the product team, you have technical resources, you have legal resources, and all these different resources have to work together to complete the project or produce the product or to create the solution. So we're a team of problem solvers. So Brian, do you want to maybe give some insights on how you approach structuring teams in your classroom for the classes that you teach?
Sure, absolutely. And one other thing that I wanted to point out, especially when you were talking about critical thinking, and we've talked about this in the past, and I try and get my students to understand this concept. When we're looking at critical thinking and developing teams and looking at coming up with solutions, we try and focus on what's working with the end in mind. What ultimately what is our goal? What are we trying to accomplish? And then kind of work backwards from that and try and determine, okay, well, what do we need as a result of developing the solution? And so to your point, we look at things from a legal perspective. We look at marketing. We look at sales. We look at the technical resources. So there's a variety of different disciplines that goes into coming up with those solutions. And one of the things that I try and get my students to understand is, think outside the box. There's no idea that's too crazy or too out there, but start with a broad canvas and then sort of kind of work your way down and get into a clear understanding of what it is that you're trying to accomplish, and look at it from a process perspective, right? So we talk about some of the things that we learned in school, like especially from a math perspective, and I know we'll get into some of this later on, but it's not so much the concepts. It's not about the fact that I've probably never used the quadratic equation before in the real world, but what it taught me was understanding, okay, these are my variables. These are, this is the solution. This is the process by which I need to develop an answer. And so it's that process that I then take into, my project teams, my product teams, and into my classroom and say, okay, what's the process by which we need to develop our solutions? And that's really what I try and incorporate into my classes, as well as even in my professional life as a project manager at AT&T. It's like, okay, let's look at the bigger picture, develop a process that will then get us to the solution that we need to get to.
Okay. And Brian, you mentioned something about mathematics and critical thinking, and what I've always understood and believed and experienced myself is that mathematics is about creating a critical thinker. Like it is a tool for creating a critical thinker.
Absolutely. It's about problem solving, understanding what you have, what you're given, and then figuring out what you don't have, so that you can then develop your solution based on what you have, what you don't have, and knowing where it is that you have to go to. And so, those are the steps and the process that that mathematics, science, just in general, provides to you. Again, we try, at least I try and get my students to understand, and then applying that again in a real world sort of scenario or situation. So like I was mentioning with my project management class, looking at trying to develop a particular system of providing, not to get into too many details, but basically providing a solution and understanding the steps that we need to take in order to get to that solution, again, in a cost-effective manner, in a timely manner, within the scope that we're given, so that we don't have scope creep, that we don't, try and do too much or more than what we're expected to do. And so it's that very well-defined process that is very important, that mathematics and science especially give us that ability. And then even the other parts of from a STEAM perspective, there's gaps within that some of the other aspects of STEAM help to fill in as well. So it's all works together, and it's all very important.
Okay. All right. Thanks, Brian. So following along this path of leveraging teams to solve problems, I found a quote, and this came from Wharton School of Business, and what it says is that teams for a complex task could do as well as the very best individual, but they were able to do it much quicker, and that's because they were faster. They generated more solutions, and they explored the space of possibilities more broadly. And one of the things that we find about teams and teamworks and team-based projects is there's learning between the team members that is as important as the learning from the professor or the teacher. And I know from business school, much of the learning came from our classmates. We had classmates that had finance degrees, marketing degrees, physicians, engineering, mathematics, and we all brought our experience, our unique experience, to the classroom. And for me, that experience was a lot more beneficial than what I was just reading in the textbook, because it added to that the data and the facts and what's in the textbook. So what we tend to do, and this applies for at the workplace, and some of the things that I'm doing with the students that I work with as a part of the HBI STEAM Academy, is we focus on strengths. So we identify the natural talent of the team member. Then we assemble the teams based on a diverse skill set that represents areas of strengths. And then we set clear goals so that the team can then go accomplish those goals, and all the team members can contribute to accomplishing those goals, leveraging their strengths. So this can be applied to a math class where students need to solve problems. So if they have a group of problems they need to solve, put the students in on a team based on their skill sets, give them the problems to go solve, let them solve it as a team. There will be some students that are weaker in certain areas than others, or stronger, but they will learn from their team members. It applies to solving for a solution. You have on a team, you have some people that are more analytical, you have people that are more organized, you have people that are more creative. So you need all those different people on a team to come up with the best product. Now, I also added something, and this is just leadership and building high performance team information. So there's a gentleman, his name is Patrick Lencioni, and I consider him to be the father of high performance teaming. And he has a book called The 5 Dysfunctions of a Team. And we also leverage this model when we're working on developing teams as well. Okay. So I've added a project that I worked on at AT&T. So I was a part of the connected car team. And what we focused on we called it the Drive Studio. It was a foundry that was designed to collaborate with car manufacturers for what we call them car OEMs, original equipment manufacturers. We collaborated on self-driving vehicles. We had a solution that was called a virtual assistant and infotainment solutions. What you'll see here on the right is systems of equations. And the thing about the systems of equations, you have multiple unknowns in the equation. And when I think about coming up with these solutions, we started with a concept. So instead of 2 unknowns, we had maybe 1,000 unknowns. Okay. But we had to use these analytical skills and these critical thinking skills, just like we use in mathematics, to take the things that we know and then come up with a solution to solve the problem. The 2 areas that I focused on in this connected car project was location-based services. So I had to come up with solutions for turn-by-turn routing, points of interest, as well as maps. So I was responsible for that, as well as developing a solution that could do over-the-air updates to the vehicles when they were in people's garages, customers' garages. So I worked with General Motors on that one, OnStar team. So that gives you an idea of systems of equation is the foundation. So this type of thinking is the foundation for systems engineering. We're solving problems with multiple unknowns, more unknowns than knowns. Okay, so I mentioned the STEAM Academy, and it's broken up into 2 parts. We offer year-round programming. Our current partner is the Urban League of Greater Atlanta. So we've been mainly working with the Atlanta Public School systems, and we've also worked with Gwinnett County here in Georgia and Fayette County as well on some of the students from there. We've had over 260 cohorts since 2016. And these students have designed during that time over 50 emerging technology prototypes, leveraging mathematical concepts along with supporting business cases. So this is where the interdisciplinary approach comes in, because the students have to solve a technology problem, a real world problem using emerging technology, and wrap a business case around it. So I have here 2 projects that students have worked on. The first one at the top is a cyber fortress. And the problem statement for the students was, and this was a cybersecurity based capstone project. The students were asked to develop a solution that protected in-home devices from cyber threats. So they came up with this idea of a cyber fortress. And a lot of what they did required the use of probability and statistics, because what they had to use data and analytics, and primarily predictive and prescriptive analytics, to determine threats and to prescribe some solution if they determined that there would be a threat. So the probability of something happening based on a certain condition. So that gives you an example of how math ties into this particular project. The other project at the bottom, this team is called Sprinting Medics. So this project here was, we worked with the sports medicine physicians at Emory Hospital that are responsible for a few of the sports teams here in Atlanta. So the Atlanta Hawks and the Atlanta Falcons. So the challenge for the students on this particular cohort was to design solutions, biomedical engineering-based solutions that would prevent soft tissue injuries in professional sports athletes. So here again, the students leverage probability and statistics, a lot, of that domain in math, to come up with predictive and prescriptive models to address this problem as a part of their prototype. So that's another example of how we use how math is used in product development. So that's the first part of the academy, is the technology and art cohorts, which is year round. During the school year, We do 8-week cohorts in the fall and in the spring on the weekends. And in the summer, we do 2 weeks, simultaneous weeks. What we're adding this fall is a program that we call Algebra Ready, and it's really for students that are not on track for algebra by 8th grade. We're trying to increase those numbers. Based on the information we got from the U.S. Department of Education, roughly about 24% of students take algebra in the 8th grade. So what we're doing is we're working with local colleges. We have partnered with local engineering schools here in Atlanta, as well as some of the historically Black colleges. And we're working with some of our partner agencies to provide a pathway for students that are not currently on track for algebra by 8th grade by providing support for them throughout the school year and in the summer to complement maybe some of their deficiencies. So those are some of the things that we're doing there. Brian, do you have anything you want to add to?
No, I think you really hit everything on the button there, especially incorporating the math part. That's always been a huge part for me. I've always been a proponent of doing well and having math skills because they're interwoven, in just about everything that we do, one way or the other, whether it's the skill itself or, like I said, the process of taking as many unknowns as you can and what knowns you have in order to come up with a solution. So I think that's great.
Well, thank you, Brian. Thank you. Okay, well, thank you for your feedback there and the extra points there. So that is it. So we'll just, this will be the time to open it up for Q&A. We also have the contact information. Please feel free to reach out. I have my email here below. You can email. The website is there and the phone number is there as well. And I can also get you, if you have any questions for Brian, I can get you his contact information as well. And I appreciate everyone's time today. So it looks like we do have a question here. Ms. Palmer asked the question, is this a separate class or ideas I can add into my math class? So to answer that question, the structure is a support model for the teacher. So we work directly with the principal, the head of the math department, and the teachers to provide after school support for the students. So we look at it as like really a white glove treatment to work hand in hand to accomplish the algebra ready status for the students. What I recommend, and I definitely would like to connect to discuss it more, if you're open to that, I can put my email in the chat and you can definitely reach out to me directly. Okay, so Brian, do you have a question to ask the audience? Anything that you'd like to know from them?
Sure. My question would be, one of the things, like I mentioned in the video, one of the things that I always try and do is, at least in my courses, and especially like Corey indicated at the college level, is trying to incorporate real world situations or real world scenarios to kind of provide a balance between what's going on, the academic material, but yet still try and sort of, drive it home to kind of help students really understand, what are the concepts that we're trying to incorporate in the learning. So my question is, is there anyone out there that has any additional experience in that vein, or have any, what are some of your lessons learned? What are some of the ways in which you try and incorporate real world situations into your classroom, if at all? I'll let you handle
Okay,
that.
so Kathy asked a question, and her question is, I was curious about the term natural strengths. How are those determined? Is there a distinction between strength and natural strength? So I would say there is no difference. It is just a better description for the kids. We try to help them understand that we all have these gifts that we're born with and these things that just come natural to us. And our thought is to leverage those things and work inside of those things and develop those things. So we just call them natural strengths. How do we determine the strength? We typically use a tool called Strength Finder as an assessment tool to get a baseline on the student's strengths. And we put them in teams according to those, the results of the Strength Finder assessment. So Ms. Palmer says some real world activities that she's done is students using Pythagorean theorem to find missing side links of an object or project they want to build in their home or bedroom. Okay, great. So my question there, did you find that you had more engaged students working on that, solving the problem using a real world experience versus solving a problem just because it's a problem to be solved? Yes. So one of the things that I definitely want to bring out, and what we have found, especially in our technology cohort, is we tend to, our approach there is to provide the students with the tools to solve the capstone project problem. But what we do is we really push the envelope on their critical thinking skills and their problem solving skills. But we do it in a way to where every single student is contributing in the ways that they feel comfortable contributing. What we have found is that even though one of the students might not be doing the analytical piece, they learn because they all have to work together like they're a real product team to pull everything together. And we incorporate business acumen into the projects as well, because they have to wrap a business case around it. So they have to understand the strategy components. So we require that they provide SWOT analysis, Porter's 5 forces for strategy. They have to understand financial modeling to go along with the technology solution. So our goal is to create critical thinkers and problem solvers, okay? And not just people that can tell you what 1 + 1 is, or what is 2x + y + z. We want critical thinkers and problem solvers. And we really push the envelope on these kids.
And real quick, I'm just going to touch on Ms. Palmer's last note there. I really like that approach there with the scientific notation, because there's so much more in just that one quick lesson, in terms of just net value and other business concepts that you can incorporate into that. So I really like that approach. It's a very good job there. And I can see why the kids would be excited and much more engaged in that than just, a plain lesson about scientific notation. So great job there.
Okay, well, thank you so much for your participation and your questions. And Brian, definitely thank you for your time as a co-presenter.